Hi, today I'm going to show you how to determine the strength of the acid, which we know is approximately 0.1, but we need to determine the exact strength of the 0.1 molar hydrochloric acid. For that, you're going to fill up the burette with NaOH. You want to ensure that it is at the 0 mark, and you also want to ensure that there was no air bubbles at the bottom. I have already done this. Then you want to take in, using a pipette pump, pipette 10 mils of the desired hydrochloric acid. You want to determine the strength of this hydrochloric acid. You want to make sure it is exactly at 0. Get that, and transfer it into the Erlenmeyer flask. You could rinse with water. The sides, just wash down the sides just in case some acids drops have adhered at the side. Pipette 1 mil of the indicator. You can see the color change in the indicator. So this, originally we started off like a purplish color. The moment it touched the acid, it's turned like a reddish pink, and we're going to do a simple titration. The titration process is you add sodium hydroxide dropwise and stirring continuously. The end point should be observed by a change in color. What is happening is the sodium hydroxide getting reacted with hydrochloric acid in the flask, forming sodium chloride and water. As the strength of the hydrogen chloride is decreasing, the strength of sodium ions are increasing. It's important to go slow towards the end. You do not want to over titrate. I can still see this color like a pinkish color. It is going to turn blue. The stirring has to be continuous. I can still see a pink if you carefully observe, and you want to make sure that that pink hue is gone out. And there we go. So with one drop it has turned a bluish green, which is what we were looking for. At this point you want to observe this is the burette reading. It starts from 0, it goes downwards, so you're going to move it downwards. It shows me to be 10.65. So that's the burette reading. So what we're going to do is simply show you what we did. 0.1008 molar NaOH. We did a NaOH, a HCl plus NaOH. We added NaOH, which gives me NaCl plus water. So if we consider this guy to be M1V1 and this one M2V2, as per our equation, we want to solve for M1. So we know the molarity of NaOH, which is 0.1008. We just determined the volume to be 10 points, actually it's 10.7 mils divided by V1, because we've taken 10 mils of the hydrochloric acid. And hence we have now accurately determined the molarity of hydrochloric acid which shows to be 0.1078. So in this way we have actually successfully determined the strength of hydrochloric acid, which was our objective. I hope you have learned this in this video how to do a simple titration. It's using our newly prepared or a freshly prepared indicator which I have extracted from red cabbage. Thank you.